Today we're going to do a heated object. I've pre-filled all the data in all the numeric entry fields to save time. So let's get started. We're going to select Heated Object menu. We're going to do a heated tank application. We've selected a cylinder that's 8 feet in diameter and a length of 10 feet tall. You might find this in a refinery site. The shell thickness is 0.25 inches, and we're going to be heating Dow Therm J. It's an oil, and that's the shell material is going to be steel carbon with the shell thickness of 0.25 inches. When we're all done specifying our object, we select Done. Then we select our starting temperature and ending temperature and heat up time. For this application, I've selected 20 degrees Fahrenheit as a starting temperature, 55 degrees Fahrenheit as an ending temperature, and we want to heat it up in 8 hours time. So we select Done, and this is where we select all our environmental conditions, which affects all the losses. The ambient temperature around the tank is, we're going to say, is 25 degrees Fahrenheit. It's going to be windy. That's kind of a worst case condition. We're going to say it's 25 mile per hour wind. The process temperature, which is the temperature we're heating the oil up to, is 40 degrees Fahrenheit. The conduction temperature, which is the temperature of the ground below that the tank's sitting on, is 32 degrees Fahrenheit. The conduction loss area, which is all the heat that goes through the bottom of the tank, will be 7,234 inches and a conduction length of 24 inches. And that's all going to be sitting on a material of crushed quartz. Again, we can select all kinds of materials to heat or for losses. There's over 230 materials in the database that we can select, or again, custom user defined, we can put in our own material. When we're all done, this tank is a vertical orientation. We select Done, and then we get our power summary. The results give us a startup power required, which is 5.366 kW. The heat losses for the system requires 7.058 kilowatts. And so for a summary, right now it looks like we need required power of 11.078 kW to keep the tank from freezing, or 37,799 BTUs per hour, which might be if we were using a gas heater. Now, if we want, we can email this summary to ourselves for archiving, or to a friend or a customer or somebody else within your company by just selecting Email Summary, which gives you a much detailed report that gives you everything about the heated object, gives you all the thermal properties of the inner material, which is of the oil, and the shell properties, and then it gives you all the startup power properties and all the heat losses. And with that, you have a very detailed archive report that you can use to send to people, or also to back calculate to make sure the answers are correct if you thought there might be a problem. So that's it for today for the quick demo. Again, we can use this demo for heated objects, heated streams, heated gases, pressurized gases, figure out heat losses. It's a very powerful app that you can use on your iPhone to solve problems real time, right on the spot, and also email yourself or customers, or use it for heat transfer course problems. If you're a college student, you can double check your answers. Thanks.